In my PhD project, we're trying to develop alkali-resistant hydrocarbon SCR catalyst for the removal of NOx gases in biomass-fired power stations. Due to climate change and new EU legislation, the firing and co-firing of biomass is becoming increasingly important at power plants in Denmark and abroad. As we can see that Dong Energy is increasingly relying on the firing of biomass instead of coal. However, firing and co-firing of biomass leads to severe technical difficulties at the power plants. One of these difficulties is the deactivation of the SCR catalyst, which is used to remove NOx gases. As we can see in this graph, using straw and wood instead of fossil fuels leads to much faster deactivation of the SCR catalyst. This deactivation is caused by the involvement of Brønsted acids in the catalytic cycle of the ammonia SCR mechanism. As we can see here, the VOH groups are very essential to this process, and they are blocked by potassium, which is present in the biomass in large amounts, leading to chemical and irreversible deactivation of the catalyst. On the other hand, we can also use ethanol and other hydrocarbons instead of ammonia. The popular mechanisms for this process do not mention the involvement of Brønsted acids, though this process should be more potassium tolerant. We have tested the potassium tolerance of different reductants, and we can see that the hydrocarbons, namely propene and ethanol, show a much higher potassium tolerance than the ammonia SCR.